Good afternoon, everyone. This afternoon session will be about the hands-on of the lecture in the morning, which taught by Sneha Sharma. And this afternoon, our lecturer is Sumit Casey from Remote Sensing and Geographic Information System of the AIT or Asian Institute of Technology. Sumit, please introduce yourself and your class.
Sumay, you view my.
Okay, sorry, I forgot to turn on. Okay. Good afternoon, everyone. I'm Sumesh Kesi. I'm currently working as a research associate at Asian Institute of Technology. So I'm pleased that Professor Panmanas invited me to share some of my knowledge on spectral preprocessing, machine learning, and deep learning, especially for NIRS spectroscopy data set. So I'm very thankful to her. Thank you so much for inviting. So with this, I would like to start my presentation. Okay, I hope you can see my screen.
Yes.
Yes.
Okay, so for this 2 days tutorial, in the morning, Sneha completed the theory part. So I will be covering the tutorial part using MATLAB. So I have divided into 6 modules. So at first we will just go to introduction about MATLAB, the very few slides. I know that every one of you know about it, and maybe you are more familiar than me. And second is getting started. So we will go through some basics of MATLAB, like how to write, how to create the variables, how to test the condition, how to iterate over some array, how to plot some data set that we have, and likewise how to create the matrix, how to do matrix manipulation, because in near infrared spectroscopy, so we are dealing with matrix of data, so with wavelengths and the number of samples. So matrix is very important, so I will go to matrix manipulation part. And third one, spectral preprocessing, which is very essential element of analyzing the NIR data set. So we'll go through that. So we'll go through various preprocessing techniques, and you are quite familiar with it. So I will just describe you how to do in MATLAB rather than focusing on the importance of each preprocessing, which you already know. So after preprocessing, we will go through machine learning, so both regression and classification. So it would be great if you can have some data set of your own, so that you can have a look how good is your data set when doing regression tasks or classification tasks. And in the 5th module, I will go through deep learning, simple deep learning network, artificial neural network. So I will give you the glance about what things are there. So how to construct a simple neural network for classification as well as regression. And at last, I'll be talking a little bit about hyperparameter optimization, so which will help us to generate the model which could perform better than using the default value or some sort of value that you fix by yourself. So before I start the introduction, I would like to know like the level of understanding about MATLAB from each participant. How familiar are they with MATLAB? So currently we have
Yeah. Okay.
So
Please continue.
yes, Azan. So yeah, MATLAB, also known as Matrix Laboratory, right? It's a high-level programming language. It's not like the Fortran language that you may have heard. So by reading the MATLAB code, we can easily understand. So it's called high-level language, and it's interactive because it's not about typing, but tools are easily available there for running the models or importing the data without coding. So it is widely used in numerical computations, visualization, and programming. So it offers a lot of functionalities like metrics plotting, so creating algorithms other than that are in the MATLAB itself, and creating models and applications. As well, like you may have heard, it has interface with other languages. So even if we open the MATLAB, we can code in Python or C++ and run in the MATLAB. So these functionalities are available now. So here is the computational power. So it is this MATLAB is widely used in almost all the domains, mostly for simulation tasks, modeling tasks. It is quite popular. Uh, so yeah, so like machine learning, deep learning, hyperspectral, or even like in the electrical domain, like communication domain, it is widely used. So there are many features. I think I don't need to tell about this. So rather than this, I will go on the getting started section. So first, I think you are quite familiar. So when you first open MATLAB, you will see. Uh, okay. So you will see a window like this. So we have many components with this. So first one, I want to go through the menu. So we have three menus: home, plot, and apps. So under each section, there are a number of tools. Sorry, this is tools. So tools are available. So for interactive part, so we don't need to code in the command prompt. Rather than that, we can just import the data set by using this function, or create the variables using this function, and everything. So and yeah, so so the third one is the working path. So we can define the working directory. So it's like a project or a folder where you have your data, you are writing your code. So you can define the working path over this area. And if there are any files in this working directory that are shown over here, so currently it is blank, but later we will see during the practical session. So we may have some data over here, or maybe Python script that are shaped already. So on the right, so there is workspace. When you create a variable, so the information about the variable are stored in this workspace. So there is help option in the MATLAB. So where you can type, okay, for example, you want to do PCA. So you can type PCA in this source box, and then you will see some useful information in other windows showing like what is PCA, how to use PCA in MATLAB, and so on. So other than that, here is one more window, sub window. So where you see the details about which code are already being opened in these sections. So next, since you have this tutorial already with you, so what I want to do is just the basics. So I will not spend much time in this one, but yeah, just simple arithmetic operations just to get familiar with. I think all of you know about these things, but if you are not familiar, we can try with these things. So yeah, the addition operator, subtraction, multiplication, division, so exponential, so like 2 to the power 8. Yeah, so like what happens when a number is divided by 0? Likewise, there are some constants which are already defined, like if you type pi, it will display a value equivalent to 22 by 7, or like some trigonometric functions. So in the earlier slide, I showed the only some of the operators, but there are a lot that you can use other than the simple operators. Like when we are doing array operations, so we can use this array multiplication operator, which is like um, full stop followed by the multiplication sign. So it will do element wise multiplication. So likewise here you see another which does element wise exponential operation, and yeah, there are more. So, and there are other operators which does very specific work. So for example, so when we are creating an array and we want to index, so we have to use this semicolon operator. So when we are creating some functions or passing some argument to function, we use this parenthesis. When we are creating array or matrix, we use this square box. um, this is decimal point. Yeah, and there are many more. So Azan,
Yes.
should we do like parallelly? So I will go first on slide, and then of the same slide I will do on MATLAB, like that.
Yes, please. It's up to you.
Okay, so I will complete some slides and then we will do on MATLAB. No? Is that?
ค่ะ โอเคค่ะ
Okay, so there are some special variables pi. So you can type pi in MATLAB and it will show some value equivalent to 22 by 7, or INF, which denotes like infinity number or not a number, something like when you divide 1 by 0. uh, and like for complex operation there is a complex number, there is ij, something like this. So okay, so before going further, I will first like to tell you about the variable. So when in MATLAB, so we have a value that needs to be stored, and we use that value to do some calculation. So those values should be saved under some name. For example, in the previous slide, you see this pi. Pi is a variable name and its value is equivalent to 22 by 7. So same like this, when we want to do some operations, like we want to multiply two numbers a and b. So first we need to define the variable a with some value and variable b with some value. then we can do multiplication or addition based on that. So there are some the rules when we are creating a variable name. So it should follow by uh, letters or digits or underscore, and the variable name are sensitive. That is, if you type small a and capital A, it means different meaning. Though in English alphabet, A and A are same, small a and capital A are same, but in MATLAB, these small a and capital A are completely different. So every variable is stored as an array or matrix. So array, we say about the vector, and matrix is the two-dimensional or multi-dimensional vector. So here is an example. So where a variable x is created, x is a variable, and its value is assigned as 101. Okay, so this equal to is an assignment operator. It assigns 101 value to x. So we create a variable like this. Okay, so here is a comment. A comment starts with the percent sign in MATLAB. So we can write comments so that we can easily understand the sections of the code. So like here I write defining a variable x and initializing its value of 101. Okay, so as soon as we type this statement, x is equals to 101, so MATLAB will execute this statement and create one by one matrix and return the result as x equals to 100. Okay. Okay, so there are different ways like creating a variable. We can create variable in a same line. Okay, x equals to 100, y equals to 20, z equals to this much, and like some operations. So we are first initializing the value of x, y, and z, and then doing some computation. Okay, value equals to x times y times z minus x. So this all statement will be executed at once, and the result will be saved as a value, and later we can print out the value. Okay, so in MATLAB, when we create the variable, and sometimes there will be many variables in one script, and we will get confused what are the names of variable we had defined. So in order to know, so we can type one simple function who. If you type who in the MATLAB, then it will give a list of variables that are already created uh, in particular script. And to get more information about each variable, okay, what is the size of variable, what is the byte, what class does it belongs, we can type whose. So it will let us know more about variable and what kind of data is stored, what is the length of variable, like that. Okay, so after this I will.
What is a byte? What is byte?
So it is the memory required. It is the one amount of energy, Azan. So the smallest storage unit is 1 bit. So 1 bit. 1 bit is the smallest storage, and byte is 1 byte equals to 8 bit, Azan. It is the storage unit, Azan.
It is like megabyte.
Yeah.
Yes.
So when we talk about hyperspectral data, we talk about megabyte or
Gigabyte.
like that. But since we are creating a variable with very small size, like it's only one element, so it requires only 8 byte of space in the computer memory, Azan.
I see. And class double. What is class double?
So it will come on next slide, but double means like it's stored as a floating number, like a decimal number, like by default, even if we assign integer, the MATLAB reads it as a double as an.
I see. Okay.
This slide we will do hands-on up to this section. So like when we are creating a program and testing, we create a lot of variables, and a lot of storage will be consumed during development of script and testing. So sometimes when you have a small RAM size in your computer, or small storage capacity in your computer, like you may sometimes run out of memory or out of storage space. So when you have completed creating the script and testing, so you can type this command clear in the MATLAB, so it clears all the variables that has been created, and the memory and the storage space will be cleared from the RAM. So you will save some memory. Okay. So let us do up to this part in the MATLAB first. Share like one. Okay, so now I think you can see my MATLAB program, right? Hello.
Yes.
Yes, Suzanne. So now we will start coding in MATLAB for some time, and then we will continue again with the slides.
Task त्यो टास्कमा गएर हेर्न भन्नु पर्यो नि त.
Okay. So since I cannot share two windows at once, I would like you to open the slide, slide and MATLAB simultaneously, so we can work together.
यता स्लाइड राख अनि यता MATLAB राख. Like this one. Yes, okay.
So I will first tell about the window. So when you open MATLAB, it is like this. So currently my working directory is D drive. So you can create your own working space. I will move to my working space over here. So I will set my working space as this day one. So I have already copied the data that I have shared with you here. So currently, if you see, so there are no variables created because we just opened the program. So first we will start just by doing some mathematical operations, like 100 plus 200. So as soon as you press enter, you will see like MATLAB executes, calculates the sum of two numbers and prints here. So here you can see ANS equals to 300. That means this 300 is automatically assigned to ANS variable. And here on the right in workspace, you can see like now the variable is created, and its value is 300. So likewise, some constant like pi. So you can see like its value will be printed as soon as we press enter. So when we are creating a variable, we have to give the name. So for example, we can say, okay, value of x equals to 5. So now here on the left, you can see we have only one variable, ans, but as soon as I press the enter, you see like another variable is created. So to know what variables have been created, so you can just type who. So MATLAB prints your variables there are currently two variables. One is ans and another is x, and it just shows what variable are there. And if you want to know more information about variables, like what is the data type, what is the size of the variable, what is the storage it requires, so you can type whos. So now it prints more information about the variable, like variable name is answer and x. So its size is 1 by 1. That means there is only one element in each variable, and it takes like 8 byte of memory in the RAM, and the data type is assigned to double. So we can also print the data type information by typing another command, like class is one function which will print the data type of a variable. For example, we have variable x. So it shows variable x is of type double. So x is storing a decimal or floating point number. Let us create another variable. Okay, so name equals to MATLAB. So we all know that this is like a string, right? So it's a text. So it should be stored in different data format. So if we type class x, it should be name. Name is the current variable that we created. So it is showing that this name is a variable of type character. So it is storing the text information. So in the slide 14, I had showed we can do everything even in a single line. So like we can create many variables in the same line, separated by semicolon. So this is the operator that is used to separate one command from next command, or one element from next element. So we can assign y equals to 5, and maybe like there is one, so we want to compute z equals to x divided by y. So we are like defining and initializing variable x and y, and computing the variable z by dividing x by y. So if you see here on the right, so there are more variables created, like y and z are created, and like you see the value of z, it has already computed the value. If we want to show, then we can just type z and see the result. Okay. So now if we want to remove all of these variables, or if we want to if we want to remove a variable named answer from our workspace, so what you can do is use the command clear and the variable name answer to clear from our workspace. So it will the memory will be released and the answer variable will be deleted from our workspace. So as soon as I press enter, you see that the one variable named ANS is removed from this one. Like when you complete running your script, and if you want to remove all the variables, you can just type clear, so that it will clear all the variables created in our program. So if you press enter, so you see all the variables are deleted from our workspace, our folder. So so now if you type who to see the variables, you see that there are no variables, so it just executes and print nothing. Hello, Azan.
Yes.
Are you following me?
Yes. I follow your teaching.
What about others? Can I know, is it okay?
Yes, it's okay.
So I think you are quite familiar with these things, right? Already?
For me, there are some trips that I don't know.
Sorry, L.
I said, for me,
Uh-huh.
there are some trips that I don't know.
Trip?
Trip is like a clear or who's, I don't know, you can teach.
Sorry, I did not understand.
You can go ahead. I mean, it's basic. For me, it's okay.
Okay. So I will continue with the presentation. Okay. So there are many data types that are used in MATLAB to store specific data. So for example, one is numeric, which stores integer and floating numbers. So second one is characters and strings, like uh, uh, these are mm, the value is quoted under single quote or double quote, as you can see here. And date and times, so when you are working with time series data set, so you will have to use this date time data type. And another is categorical array, like when we are doing classification tasks, so we will have some labeled classes, so we can use the categorical array. So for example, in case of Sneha, like she can use categorical array as a data type to store ripe, unripe, overripe information. It can also be used in some of the participants' uh, project. So another is table is another data type, which are generally used when we are reading CSV file, Excel file, or text file separated by comma. And there are more data types, like which we will not use, and that's why I didn't talk about. Like there are structures, cell array, function handles, which we will not use in this tutorial section. So second, I want to talk about creating the vectors and array. So when we say vector, it is a one-dimensional array of numbers, and so we can create two types of vector. So one is row vector, and another is column vector. There are like specific ways to create row vector and column vector. So first one in the row vector. So it is created by enclosing set of elements. So elements means like 2, 3, 5. These are the elements of the array. So when you are creating array, so first we start with this square bracket, starting square bracket, and we define the numbers either by space or by comma. So both is acceptable in MATLAB. So we define number of elements, okay, 2, 3, 5, 7, and we should enclose by closing square bracket, and then an array will be created. Row array or vector will be created, as you can see here. So when creating a column vector, so it's a little bit different. So we denote that the element belongs to another column by using this semicolon operator. So column vector is created in the similar fashion like a row vector. So we start with starting square bracket. We define elements of row. So for this, each row contains one element. So 2 is the first row, and we write a semicolon to define that. Okay, so now we start another column, another row. So another row, and 3, and again semicolon means after 3 we'll create another row. So in this way we can create column vector. So you can see the difference here when creating R1 and C. Like when we are printing, it is showing us whether it is a row vector or column vector. So definitely it's horizontal, so it's row. So it's vertical, so it's column vector. So like in simple numbers, we can also do arithmetic operation, trigonometric operations, etc. In vector. Like generally, when we do arithmetic operation, it is element wise. So for example, here we have a row vector of 5 elements, and when we multiply by 5, so the 5 multiplies to each element of the vector. So 5 to 10, 5 3 15, 5 5 25, like this. So when we add, it's same, or even when we divide, so it is done element wise. Likewise, we can do trigonometric operations like sine or inverse of sine, hyperbolic, like that. Likewise, there is one useful function, length. So you should remember this, because we'll be using later when we are doing pre-processing, or maybe even when we are doing machine learning, we can use this length, because it gives us like the number of elements present in the vector. So not about this, we'll use later. Likewise, there are many other functions like sum, which outputs the sum of all the elements of the array. So likewise, we can do addition of not only the number and vectors, but vector and vector. So it is done element wise, but if the length of vector, so here we can see that, so both R1 and R2 has 3 elements, so it can do operation like addition, subtraction, like that. However, if R1 had 4 elements and R3 has 3 elements, then like this addition of vectors or multiplication of vectors is not possible. So the size of vectors should be same when we are doing some computations. Likewise, we can do element-wise multiplication of vectors. So for element-wise, we use this operator, full stop followed by apostrophe. Sorry, what do you call for this? Star sign. Yeah. Full stop followed by star sign.
Asterisk.
Yeah, asterisk. So it means element-wise multiplication. So you have to note that this asterisk has a different meaning in MATLAB. So it generally is used to refer to matrix multiplication, not the normal multiplication. So if we want to do element wise, we have to use full stop followed by asterisk sign. So another is the relation operators. These can be useful when we are working on machine learning part. So like we can check whether the two element wise whether this elements are same or not. Like here, so R1 equal to R2 means like if like the corresponding element of R1 and R2 are equal or not. So in our case, since like if you see over here, like there are no common elements, so it prints 0 0 0. So it is of type logical array, means this means false. So 1 equals to 4 is not true, is not equal, so it is showing 0, which means false. So I have a small task for you before I move further. So like since this is like the basic part, so I want you to create an array of these three tasks, like create array of first 5 multiples of 7 in single row. So we are creating row vector. So here we are creating row vector and column vector. I would like you to try, and if you have completed, then we can continue further.
I don't understand what is first 5 multiple of 7.
Oh, okay.
7 1
Like-
7 7
like,
to the 14, like that one.
we will create an array of like
7 14 21
14. We go like 21, 28.
28 and 35.
Oh, I see. Okay.
Okay.
Okay, I think everyone has completed this one. Has everyone completed?
L June.
Yes.
Finish?
Yeah.
Okay, if finish, then you can show, right? Or no need to show?
No need to solve for now. Maybe later, if have any problem, then I will look at your monitor and like give you suggestions how to solve. Like this one is simple, but I have some other tasks maybe more difficult later on. Okay, so then I will continue with further slides. Okay, so before we it was about a one-dimensional array, but this slide explains about creating matrix, and maybe in further slides we will work more on matrix only, because we want to focus on processing near-infrared data set. So matrix is a two-dimensional array, or it can also be multi-dimensional array. So we can create from here. So when we are creating a matrix, so like we enter row by row, like and then and we end each row by a semicolon. So like here, so we are creating matrix M1, where like these are the elements of first row. Then we use this semicolon to say like we are creating second row now. So this is element of second row and element of third row. So like this is how we create a two-dimensional matrix. And here it's same, but we are creating a matrix of like 3 by 4, 3 row by 4 column. Okay, so after we create a matrix, so we can check the dimension of the matrix. So when the matrix is very small, we can check by ourselves by printing. However, in the case of NIR dataset, we will have hundreds or thousands of wavelengths and maybe hundreds or thousands of samples. So in that case, we cannot know the size by printing. So we have a special function to print the size of the matrix. So after we create a matrix, if we type size, and inside the parentheses, if we give the matrix, then it will print, give us the number of rows and number of columns. So first element represents row and second represents column. So when we are doing matrix based operation or manipulation, so we need a number of automated matrices for faster computation. So in that case, we have some ready-made functions in the MATLAB that we can use to create matrix or vector. So see, here are some few examples on the left side. So first one is a linear space. So it creates a regularly spaced vector. So I will show the example later. There are other like log space. Some of the functions for creating matrix like zeros. So it will create a matrix of all elements 0 as a 0 and ones. That means matrix with all the elements of 1. I. So it will create the identity matrix. It's a matrix with diagonal element 1 and other elements are 0. So or even we can create some random matrix with random elements. So there are some useful functions to extract statistics or information about an array of or matrix like length, which gives us the number of elements in an array or in a matrix. Likewise, size, which gives how many rows and how many columns. So that is dimension. So we can return like print out the minimum value, maximum value, sum, either in row wise or column wise. So here are like some of the examples. Like here we are creating a variable z and we are using a linear space function. So where we are, this is the starting number. So from where? From 2. Like this is from 2 and how many numbers? So here it will create 5 numbers between 0 and 100 and equally spaced. So here you can see 5 numbers. Same for logarithmic, but it creates in a different fashion, different way. It's not so important for us. Like these things are important, like 0 matrix. So here we are creating a matrix of 2 row and 3 column with all the elements 0. So likewise ones. So matrix with all the elements 1, and the identity matrix. So don't forget about this 0 and 1 matrix, or even identity matrix we may need later when we are doing spectral preprocessing and machine learning part. So these are some examples to extract the statistics, or like knowing about this dimension of matrix or array. Here you can see like size prints how many rows and how many columns. The length prints the length of the array. Likewise minimum, so we can print column wise minimum. So here A is an array, and when we type mean of A, then it prints column wise mean. So first it goes to first column. So here the smallest element is 2, so here it will print 2. For the second row, the smallest element is 1, so we get 1 here. For third column it's 2, so we are getting 2, and for fourth column it's 0, so we are getting 0. So if you want to calculate column wise mean, so then we use this function. Likewise column wise maximum, so there is a function called max. So column wise sum, there is a function called sum. Okay, so and another is we want to calculate the minimum of this whole array, not row wise or column wise, but whole array. So we can use this command where we are saying minimum from A, and we want from all. So we are using this syntax to find the smallest from the matrix. So same is for maximum, and for sum, so it is the syntax is a little bit different. So here we talked about column wise. So this one we are talking about column wise. But if you want to calculate row wise statistics, then we have to specify the dimension. When we are doing column wise, we give we do not pass any dimension, but we can also pass like A and 1. So it will perform column wise. Whereas if we want to do row wise statistics, then we will pass an argument 2, which represents row wise. So we can compute mean, max, sum, mean, standard deviation of from the array or the matrix. So as you can see here, for row wise we use 2, for column we pass an argument of 1. So in matrix there are many operations that we can do, and it is important when we are doing like PCA, or when we are doing PLSR and the decomposition techniques. We use a lot of matrix operations. So like there are function to calculate determinant of the matrix, inverse of the matrix, this transpose function just alters the row and column of the matrix. We can reshape, we can sort, we can calculate the cross product and dot product, we can calculate the rank, and we can also convert it into row equivalent form. So this is just to show about the dot product and the cross product. So these are useful in decomposition, but I will try to deal with it if we have time about PCA and PLSR. So there, we need to use this dot product and cross product. So one small task from here. Create a matrix of 3 into 4 shape matrix. So you can tell me when you complete this creating a matrix with any numbers as an element.
Can I random?
Yeah, any value is fine for now. Okay, I believe everyone has completed.
Yes.
So I will continue with indexing and slicing. So suppose we create an array of 3 elements. We create an array of 3 elements, 0, 5, and 8. As soon as we create, MATLAB will index the file. So and the indexing starts from 1. So this is the starting number. So it will give index value of 1, and 5 will be indexed as 2, and 8 will be indexed as 3. So in MATLAB or in any other programming language, we can access each element of an array. Let us suppose an array name was A has 3 elements 0, 5, 8. Now if we want to access the first element of an array, so we can just write A, and when we are accessing the elements like first element, we just pass 1. So it is saying that give me the first element of array A. So this will print out the value 0. Okay. So suppose, and we want 2 elements 0 and 8. If we want 2 elements 0 and 8, we can type A 1 from 1 and to 2. So it will access first element and second element. So this sign colon represents like from this point to this point. Okay, so we are accessing first and second elements of array A. So it will give us 0 and 5. So yeah, so slicing is this operation. So we are extracting subset of one whole array. So we are accessing only 2 elements from 3 element array. So this is called slicing. And so indexing is this one. So every elements of an array will be indexed starting from 1 in case of array. So when we are talking about matrix, so this is 2-dimensional array. So let us see over here. So we are creating an array of size 4 by 4, 4 by 4. And now we want to access element 10. So element 10 is like, or for now, we just say like we want to access number 10 from this array A. So what we need to do is we need to define its position based on row and column. So first we should look at row. So 10 is like first, second, third row. 10 lies in third row, and it also lies in first column and second column, right? So its position is written as 3, 2. So that it means like 10 is situated in third row, second column. So when we want to access 10, we have to give the row position. So here you can see we are accessing the normal 10. So likewise, if we want to access all row, like second row, that means second row means this. So if you want to access elements, all the elements from this one, so then we can say, what we can say is like this. We say that we want second row, and in order to denote all elements, we can use this colon. So this means like it will start here from 1 until the number of columns. So here is 1, 2, 3, 4 column. So it is like 1:4. Okay. So otherwise, if we want all elements, we can just write this colon symbol, and it will access all the elements belonging to that particular section, a row or column. So likewise, here we are accessing the third column. So all the rows of third column. So that means here we define all row by using colon, and to denote the third column we use 3. So we are getting the third column of array. Or in similar way, so this is the shortcut. But if you want to type more, then this prints the same thing. Like we give the index of each element. Okay, we want first row, second row, third row, and fourth row element from third column. So it means the same. So being when programming, doing in the short way is better, so that it can save time. Likewise, when we type many things, sometimes we may forget to type a comma, so which will give us error. So rather than consuming time, so we can be efficient by typing less code. So we can use things like this. So there are more examples. There are many ways, but yeah, don't forget that when we are when we want to access the elements, so we have to give the row position and the column position. And like if we want to access only some elements, so here I have shown slicing. So you define the starting position and ending position, and we can access the elements. So this is the same example. Like here, I don't want to access all the elements of each row, but only a particular row and particular column. So we can do this from here. So here it is saying like I want all the elements from first row to fourth row, but only those that belong to second and third column. So what we are getting is this portion. So um, elements from all rows that belong to second column. So this is first, second, and third. So we are getting these two columns. So there are other ways to extract the element, but for now I want to skip this part because this will not be important, but this is all about indexing. Yeah, so I want to give one small task. If you are familiar with indexing and slicing, otherwise I will show some demonstration before I give you a task.
So Ajahn, can we do the task first?
Yes, I'm trying, Now I got 4 multiplied, 3 multiplied by 4 matrix.
Okay.
Yeah, I try to extract.
Extract the last element of the matrix. Ajahn, can you get it?
I cannot separate the, I write like this. I write A equal to, in the parentheses, 1 colon 3, and then comma 3 colon 4, and then in a parenthesis. So it's wrong. What should I correct?
Yes, so you can see I have created one array of 3 by 4. So first one, if you want to extract last two column, so last two column is this one and this one.
Okay.
So what you can do is, so you want all the row from last two columns, so you can say 3 and 4. So
but the task is extract the last element of matrix. So that should be A3, 4.
No, this first is last two column.
Last two column. Okay.
And for second task, extract the last element of an array. So last element of array is
3, 4.
third row, fourth column. So we can type 3, 4.
Mhm. Now I got it. Now I got it.
How about other? L.
Finish.
Okay.
I got the first point only.
So second point.
It's okay. It's okay. You can continue.
Yes, son.
Okay.
So okay, just to remind you, so like we'll not go in detail about these things. Just to let you know, like there are many formats in which we can display the data. Like in general, this format sort is by default. That means it will display up to 4 decimal place. But yeah, so if you want to display up to two decimal place, there is another format called format bank. So you can just type this command, and if you print the value again, so like here, so first is this, but if you use bank, then it will display up to 2 units. So it may be useful for some of you to have to fix the format. And I think mostly this will be useful for us, like rounding. So when we want to round some value to some digits, so we can use this function. So first we pass the value like 3.1415, and if we want up to 3 decimal place, then we can put 3 over here. Okay, some useful commands for all of you. So like maybe now if you see your MATLAB command line window, like there are many things, like you had done many operations. If you want to clear everything from command line window, you can just type CLC, which is like clear screen command line. So this I have already talked, like if you want to remove the variables to uh, restore the memory, then you can use clear command to remove all, or if you have a specific variable like x, so you can say clear x, so x will be deleted. So whose I have already talked about, so just to list the variables and information. So this could be useful later, like we have already set the workspace. So now if you want to know if there are many files, and if you want to check by coding, you can type exist, like some script. Okay, some script like okay x.m. So m is the extension of file. So if you want to check whether x.m file lies in the workspace or not, so global is to create a global variable. So maybe we'll not use over in this tutorial, but another useful command is help. So like when you are confused, like how to use PCA, or what parameters to pass in PCA, like in PCA we generally pass a matrix and the number of components we want to get it, and the solver method, like whether we want to use SPD or NIPALS or any other algorithms available. So you can get information about that using help. And so there is other commands like look for, and quit is just to exit from the MATLAB, so it will just close the MATLAB. So other than that, there are other commands like I will show you when I will read the file that I have provided, one sample file. So we will use that later to display which directory we are in. If we want to change the workspace from one directory to another directory, we'll use cd. If you want to check what files exist in the current directory, we use dir. So like that. If we want to load some file, we use this load. If we want to save, we use this save command. So for deleting, we use this command. So I will I will show you later when I will open the file. So this is just for input and output. So there are many functions which are used to display, like, so we use this command to print. So if you want to print some message like a character message, okay, the value of a is 5, then you use these 3 different functions. And if you want to take input from the user, okay, I will show the example after a few slides. I have one example about this one. So if you want to take input from the user, like you have created one application which takes a number from the user and tells the program will tell whether the number is prime number or not. So you can use input function to take the input. And this semicolon has one more useful example, more useful case. I will show this later. So when we are printing number or like character or anything, so we can use this like format specifier along with this one. I will show one example in few slides about this thing. So I want to also show you some examples about creating the plots, like when we are creating the plots, what things we need to define and how to plot. So simply, it's very simple. We use plot command, but we pass 2 variables. One is x and another is y. Okay, so we need to, before we pass x and y to plot, we need to initialize the value. Like here, y is x to the power 2, so, and x is defined like this. So when we um, type these 3 statements, then MATLAB will show the graph automatically. So like when we say visualization, and when we are talking about publishing in scientific papers, where when we want to make it understandable by looking at the graph, we need to add many elements in the graph, like the title, maybe the axis level, maybe we need to add just some other things. So we can do that by using some commands like x level. If we want to put a level on the x-axis, so y, so we put on the y. Title, so it goes to the top of the graph. So like grid on, so here you can see these grids which are in gray color. So we use that to create this grid. And x is equal, so here you can see like it's nearly here, nearly like a square plot. So we can um, use these functions to make a graph more meaningful, so like and more visually appealing. So sometimes like we need to plot multiple data sets in a single graph for easy comparison, easy analysis. So we can also do that So there are two different, here I have shown two examples, so but they are like quite similar. Or later I will show you another function called subplot, which can be which will be helpful for you to creating multiple graphs one after another, rather than overlapping in the same graph, which can be noisy sometimes. So yeah, don't forget we need to define the variable and initialize with some value. So here so we are creating one array with how many elements is this? A lot of elements. So we are creating the array. So this is the starting and this is the ending, and the interval is 0.01. So there are like I'm not sure, but a lot of elements in X, and we are using one function to compute y from x, and then like another function to compute g from x, and we are plotting two different functions, like one is xy and another is xg, and here we are defining different color so that it will be easy for us to understand. And even we can put legend. So for legend I have shown over here. So for two graphs we can also put legend in the graph. So, and annotation. So sometimes I have seen uh, um, in when analyzing the pre-processed spectra, like in the derivative and so on, like we need to highlight some peak points or some important wavelengths in the map in the graph. So we can also do that by using the annotation function. So and we can pass some message like here. So this is one quadratic function. So I'm plotting a quadratic function, and I want to highlight the minimum point. So I'm just drawing an arrow and writing the text. So you can do similar in uh, when you want to create graph of your own data. So yeah, there are many functions to make a graph more meaningful. So we talked about plot, title for adding title, X level for creating leveling on the x-axis, y level, leveling y-axis. So we can set axis limit, like how from which value to which value. So we have, I showed you about the legend, grids. So we can print the plot or save the plot, which I will show later, and we can close the plot. So yeah. So some other things like putting text or creating multiple graphs, so we want to create uh, two graphs in one figure. So we can do that using the subplot function. So I will show this later. So yeah, and there are some functions like refreshing the graph as we are creating more and more codes, or revising the code. We can do that. So before going to this task, so I'm just giving you a small task to create um, um, a scatter plot. So I have given you some hints, like we will use um, plot function, or we can also use scatter function. Like I have given only three values, so that it will be easy for you to type also. So we can do that. But before doing that, uh, I want to let you do some try on working in some graphs. And if you have any questions on any part, so you can ask me. Hello, John.
instruction.
Yes, Suzanne. Like, what about others? Do you have any question?
Sumit,
Yes.
in the data set of X is a 0.01 is the, what is this?
That is the increment. Like every 1 point will be created by adding 0.01. So for example, here, just a moment. In this example, here you can see, right?
Yes. We
So
can change, right?
yes, so the first point will be 0, second will be 0.01, and third will be 0.02. Yeah,
Okay, I got it.
yeah. This is a start, and this is end, and this is increment. Like every time a new value will be created by adding this 0.01.
Okay, I understand. Thank you.
Any questions from May and L?
Bangkok.
Sumit, may
Yes,
I
ma'am.
ask you about the plot X and Y, and then you said it's like I don't know, the dash and I in the dash, in the two dash, and
Yes,
then
ma'am.
X and G, and then in the two dash is a G.
Mhm.
I try to plot the graph. I can get the graph, but I don't know where is R into dash and D into dash. I get the, I get two graphs in my picture.
Yes, ma'am.
Yes, the red one and the green one. Yeah, but I don't know what is the G in a two dash and R in a two dash.
It's the color.
Ah,
It's the
so
color.
Oh, it's the color. I see. Okay.
Rita, so this is red
Red,
and this is green.
I see. Thank you. Thank you.
Yeah.
Sin x cos x. So in everyone remember in Excel we use legend, right? So here also we use legend. The function is the same for legend, and then we give what we want to put in legend, like sin x and cos x in the graph 2.
So I have shown one example here. Like if you want to plot two graphs in not in the same graph area, but you want to create separate, but in same figure, so you can use this command like subplot. So we'll use subplot to create two graphs.
Sumit,
Yes, Azan.
what is 211 and 212 in the subplot?
Ah, okay, Azan. I just shared one photo in the chat. So here 2 means like there will be 2 rows. 2 row
Yeah.
and like 1 column, and this is indexing. Just a moment, I will draw this in PowerPoint. Okay. So I write subplot 2, 1, 1. It means like we are using subplot, and here this means how many figure in row, how many figure in this is row, and this means column, and this is index. So we are creating figure like this, 2 figures in one, 2 plot in one figure. So one is here in the top, and another is here. So this is row number, so there will be 2 row. So this is first row and this is second, and there will be only 1 column, so we have only 1 column here, and 1 means the first figures, so 1 1. So that first subplot 211 will plot in this chart area, and like in the second we use 212, that means second row first column, second row first column and second figures, that means over here, so it will draw here.
Oh, because you should have another one, right? 212, right?
Yes, Azan. So that's why another is 212.
212 is the second picture.
Yes, Azan.
But in the same chart.
In the same, yes, Azan. In same figure, we have 2 plots. So this may be useful when we are plotting raw data, raw spectra, and like pre-processed spectra. Like in, I think more useful in first derivative, second derivative, if we want to compare in particular wavelength.
Plot XCR. Kita lihat dulu.
So I think this task is not so difficult. Like, just need to add one small thing.
How about everyone?
I'm finished.
That task part, right?
And you can separate into plot.
Yes, it's plot in the line, but it's scatter in the dot.
Yes, scatter is the graph.
No. In scatter, in plot also we can not as a line, but as a as a point. I will say here.
Bukan lah kita lihat saja. Minimize. Ayo. Berapa? Cipta.
Tulisannya banget.
अरू कुनै के खोल न यहाँबाट के अनि खुलिरहेछ त्यसलाई पनि जानकारी गरेर
Continue. That is bad. Yeah, June. Yeah, if you want to plot as a point in For the task using plot, you have to use something like this. This is just for color, like plot data A and B, and this small b represents in blue color, and this asterisk means like that point will be plotted as a star.
I will try. Oh. Yes, I get it.
Okay. I think so. Should I move forward, or is anyone having any problem or any questions?
You can continue ค่ะ
Okay. What about y'all? Already finished? Okay, then I will continue the presentation. If you have any questions, you can tell to me anytime. Okay, so the small information to you, like as I told, if you need any help, then yeah, just type help and the function name. Okay, first one is PCA. Okay, if you want about PLSR, you can type PLSR. So it will display like the information about it, what variables will it need, like here it is saying X, and what things it will return, like coefficient, score, weight, like that, or even the t-squared, maybe some statistical test it will return, or even like explain variance over here. So we can know more about what input variables we need to give to the function, and what outputs we can expect. So likewise, I will recommend you to type this one. It will give a lot of examples about many things, like metrics. Here we have plotting, the creating the functions, or even on machine learning, deep learning, hyperparameter optimization. So you can find a lot of useful information in this one. And like I also took some of the help from this one, because yeah, so this is like a friend of me when I was creating this tutorial. So now a little bit, I have some few slides, and after that I will move on to spectral pre-processing. So maybe like all of you are excited on doing some coding on spectral pre-processing and seeing some pre-processed outputs. But before that, I want to just give some information about this control statement. Like, so there are some a number of control statement, like First one is condition or branching. So like just if else, like Isnea told in the morning, like in decision tree, right? So there are a number of subtrees where in each node they check the condition whether the value is greater than this or not. If less, then go to this branch, otherwise go to this branch. True or false. So based on that, it keeps on branching, and at last you get the classification or regression value. So actually, if you go deep in decision tree, you will find this if else um, statement. So so that I thought like, oh, why not to explain these things, because these are the basic things, but the complex things like machine learning, deep learning are also based on these small things. Okay, so that's why I put these slides. So another is iteration. So like, for example, we need to iterate over the samples, so process each spectra one by one. When we are doing with SNB or mean centering, we are treating each spectra separately actually. So we can use loop, or there are some other ways to do efficiently to reduce the coding time or processing time. But these are some of the things that we can use when pre-processing the spectra. So there are other statements, but I will not go in detail because these are just the preliminary things. But our focus is on spectra. So yeah. So when branching, there are some logic operators, like as I said earlier, whether the value is greater than 5 or not, less than, whether the value is exactly equal to 5, less than, or some multiple conditions. When we have multiple conditions to test, then we use this logical AND or not equal to or logical OR. So here is I have created a simple example to determine whether the number is even or odd. So this you can test later, but first I will explain it. So here I said before, this input is one function that takes that waits for the input from the user. So if you type this statement, a equals to input enter a number, it will ask for it will wait for you to enter a number in MATLAB. So once you enter one number, like 2, 3, 4, 5. Okay, for me I input 5. So here it is saying that 5 is odd. This is output, but yeah, it waits for input. And now here I'm using the if else condition, like uh, uh, if the value is negative or 0, then I'm saying that okay, you entered 0. I don't want to say it's odd or even, so I did one condition here, or else. So here mode of A2. So this mode is one function which returns the remainder of some division. So here the 5 by 2 has a remainder of 1, so the it will display 1. Yeah, it will display it will output 1. So this is to print the remainder of the division. So if there is any remainder when dividing by 2, then if there is remainder, then obviously it's odd. So here we are printing odd using the sprint function. This is for output. And if not odd, then it is surely even. So we are using this condition. So you can see here if, else. So this is called condition or branching. And when you are using this condition or branching, at the end you should end with this end statement. This statement tells that this is the end of the condition block. So as a whole, this is one block. So we can say one block. So end signifies that it's the end of the block. So here, like this sprint will print what we have inside the parenthesis. This is the parameter. So here I'm using %d as a the specifier. So that means this a will go in place of this one, and it will be stored as an integer. So this d means integer. So if you go back to some few sites, so I will show here. So yeah, over here you can see that d means format as an integer. So like if we want to print some text, we use %s. If for decimal values, %f, like that. Okay. So yeah, so this is condition. So do you have any questions?
No ครับ
Okay. So these tasks I will not give you now. So I want to now start the spectral pre-processing soon. So you can try this at during your free time, and maybe tomorrow you can show me. And if I have any problem, I can solve.
This is homework.
Okay. Okay. Next one is looping. Like so, like just run the same function or operation again and again. So this is looping or iteration. So there are two kind of looping so we can do. So first one is for, so for loop, and second is while loop. So it does the same thing, but like just some syntax like is different. So here you can see in for we pass syntax as like this. So for, so we have to do some initialization. So index equals to value in values. So that means we give an array or matrix here. So we pass an array, or we pass matrix over here, and we iterate over this one, this array or matrix. And so each time it will get one value from an array. So for example, over here, so here we are writing for I is 1:10. So this 1:10 will create an array from 1 until 10. And each time one element is passed inside this for loop. So, so at first iteration, one will go inside here, and this is a display function just to output the number. So it just to output. So first one will go display 1. I will be replaced by 1, so 1 will be displayed at first time, and second time it will go 2 will go here, so 2 will be displayed, and then 3 will go, 3 will be printed, like that up to 10. So like one element at a time enters inside the loop, and then some operation is performed, and then the output is generated. So it's same for all here. As you can see, like it's same, just printing the number. So I think this is wrong, but yeah, this should be I, but I put A, so there is something wrong. But it's fine. You have to know that in looping, this is done element wise. One element enters the loop, operation is performed, you get output, and second element will enter, like that. And the loop should end with end. while loop is also same. You have some conditions in while loop. So here you can see, like, first I initialize the value of I to 5, and I want to do some operation as long as I is less than 10. So, okay, so here I write the condition: if I is less than 10, do something inside. So what I'm doing here is just printing the value of I, and then I increase the value of I by 1. So first time I is 5, so is less than 10, it's correct. So that means 5 will be printed here. And then the value of I will be increased by 1. So next time value is 6, is less than 10, right? And then 6 is printed. Now this goes here. The value will be 7 as it is increased by 1, and the less than 10, correct? Then 7 is printed. Again, now value is increased by 1, so it is 8. It is right. So 9, and value is 9. It is also true, less than 10. So this is printed. And now at last you see value will be 10, but 10 is less than 10. It's not true. So it will end the loop. So it will come here and finish the loop. So it is done like this. So okay, so this task I need to revise, but I will give one task over here, maybe later on. But yeah, so okay, so we have 2 slides, and then I will move to spectral pre-processing. So the last thing I want to tell you on basics of MATLAB is creating the functions. So do you know why functions need to be created?
To calculate or not?
Yes, Azan, like functions are created to do some specific task. Yes. And other than that, anyone?
Because if we have the function, we can run only one time. It will be finished everything. No need to use more time for make process more process.
Yes, you are right.
Yes.
Yeah, thank you for explaining. Yeah, so the reason of creating function is, like, I will say there are 2 reasons. So first one is as Azan told, to do specific tasks. So like if you want to do pre-process the spectra by SNV, then create one function of SNV is fine, right? So another is as Pime told, so another thing is we don't want to write the same thing again and again. Suppose like we have 5 sample group. So 1, 2, 3, 4, and 5 sample group, and we want to do SNV. We want to pre-process using SNV. Then it's like what I can do is, when I use this sample, I will create SNV here and run this one. Okay, so I create SNV here, and I also create SNV here. For each, I will create SNV function, SNV, and run in the individual file. So you see that I am creating SNV function 5 times, right? So here I am creating 5 times. So it's better, like, I have only one function and I can use in all, so I can reference to this from all. So this is why functions are useful. So one is to do specific tasks and another one is to reduce the coding time. So I can write one function, save as a file, and then always call that function from wherever I am and get the output. So in MATLAB, functions are created using this syntax. So we have to write this function keyword is compulsory. Then here we define the list of output, like what output to expect from my function. So this is the function name and we pass some parameter here. So for example, if you want to do SNB, then inside SNB you should pass at least you should pass X. So where X is like one tabular data. So where this direction you have wavelength and this direction you have sample number. So for SNB I can pass only X and this function will return X corrected, right? So SNB corrected. So here in case of SNB it will be function and then inside this there will be XC and here the function name is SNV and I have only one input, that is X. So we create the function like this. So these are called arguments. So like, and we can have multiple arguments depending upon the requirement. For example, in case of derivative, when you are doing a derivative, like with Savitzky-Collet smoothing, then we need to pass derivative order and the window size for smoothing and the polynomial order, like that. So we can pass multiple arguments over here, and the output can also be have multiple arrays. So in function we cannot create from command line. So we have to use we have to create a function file. So so from this part we will be doing on the script file. And once the function part is complete, so this is just the function creation, but inside here we have many things like operations, and then at the end we should complete the function with in keyword. So here is one example, like suppose Azan wants to create her own MATLAB function to calculate mini score of 6 students in her course, and here are the score of 6 students. Then how can Azan create the function? Okay, so so first we create a new script. So I will show after a short time. I think Pime and all of you may know this one. So we create a new script file. Then we define the function. So function is my stats, and we pass this number over here as an array. And so from this stat we want the average value. So this is output. We put it inside an array. So and inside the function, what we do is we get the number of records using length function. So length function will give how many elements. There are 6. So this will be n will be 6. Then average is sum x by n. So will be average, and this average will go over here. Okay, and then we end with keyword, and we save this file. And after that, in the command line, we can create this score of 6 students, and just call this function here, and then it will display the average value.
Yeah. May I ask where we can write our function development, develop our function where?
Yes, Azan. I will just tell now. I will do together with you all.
Create new script.
So okay, so we have to create new script. We cannot write function here in command line. So we do that by inside of home there is new script. So we click here, and then it will open up the editor. And now we can save by Control S, and we will save in the same directory like this training day 1, but we have to give the name. So I'll put the same name as in the example, mystats.m. So m is the extension of MATLAB. So we can save. So now
I cannot follow you. How do you get the name of your function?
okay, Azan.
Yeah.
So okay, so I will do together with you. Okay, so first you have gone to this one, right? New script.
Yes.
So okay, then this editor untitled something will come, right?
Yes.
So then you press over here. You can do save,
Oh, I see.
or you can do Control S is also fine.
Yeah.
And then you give same name as stats.m, and then save. Then you will see that file in current window, current folder window in the left.
Yeah, I see.
Okay, so now we can function. So we will return average, and the function name is mystats. So one thing I want to tell is this name of the file and the function name should be same. So please note it, because sometimes we may have different name for file and function. So make sure this file name is mystats. So function name should also be mystats. And one more thing is indentation. I want to tell you that to make a code readable, please give a tab, one tab. So once you finish writing the function, you just save it.
मेरा तो 6.5 है.
I think everyone completed already.
I'm not finished yet.
Oh, okay, Azan, we wait. We will wait, Azan.
Yeah, thank you.
Asan is doing MATLAB on laptop, right?
No, yeah, on laptop, yes. Yes, Sumit, you can continue, please.
Okay, Azan. So, yeah, like yeah, this is the the way to create any functions. So, yeah, just remember the syntax. It will be easy. Yeah, so I will continue slides. Okay. So yeah, I have one task. So this is also homework. You can try. I have already created like odd even function in if in the branching part. So I want you to like create a function. So before was just a list of statement, but here I want you to create a function named test or even. So that will take a one integer and prints whether the number is invalid. So invalid is less than equal to 0 or and even or odd. So you can try at home, or like tomorrow if you have any problem, you can tell me. So we completed module 2. So if you have any questions, I think it's tiring and boring.
What?
Like we completed module 2, like and if you have any questions, you can ask me about module 2. So now we will go little bit on spectral preprocessing. So I will continue with spectral preprocessing. So yeah, so there are many spectral preprocessing techniques, but I will cover these 7 different ways. So baseline offset, mean centering, smoothing, SNV, MSC, mean max normalization, and derivative with Savitsky-Golay smoothing. So generally for our case, the data format will be in this way. So the first column will be our response or Y. So it can be numeric, like when we want to estimate TSS or fat content, or it could be categorical like unripe, ripe, overripe. And other columns will be the wavelength, so our predictors or the independent variables. So this one is just for demonstration, but tomorrow we can work on the participants data set. But for today, I have taken this sample set from SNEA's master's experiment. So she measured TSS and she had
wavelength from 400 to 1000.
yeah, okay. So we'll consider wavelength from this to 1000. So I'm pretty sure like all of you know about the formula for how it does how it pre-process the raw spectra. So like SNV, it's just the what do you call it? It's like a JT score. So yeah, it's a JT score. So multiplicative scatter correction. Here we predict we estimate the what do you call, like slope and the bias from the reference spectra, and then make correction on the raw spectra based on the estimated parameters from the reference spectra. If we don't have reference spectra, the general way is to take the mean of the raw spectra as the reference and do correction accordingly. So I will show in detail like how we can do this. And just mean normalization, the mean of each spectra, we calculate, and we divide like
raw spectra
with the mean spectra. Yeah, so Savitsky-Golay smoothing. So it's like a local polynomial least square fitting algorithm. So that can be used when we have like.
May I ask the previous one? Yes. You said the normalization. This one is the raw spectra divided by the mean spectra or the mean spectrum.
Sorry, Atan, one more time.
Yeah. It is the normalization.
Yes.
Normalization is the, you said is the raw spectrum divided by its mean, right?
Yes, Alan, it should be.
Okay, not mean spectrum.
Yeah, divided by its mean.
Mean of that particular spectra.
Okay.
So we will work on Savitsky-Golay. So this one is like a little challenging when we do by coding. So this one I will explain tomorrow, but the basic pre-processing I will do together with you and make it clear about it. And like, yeah, first derivative, second derivative, this part we will do tomorrow. And another is baseline offset. Yeah. So this I have generated already from the raw spectra, that the sample raw spectra that I have shown before. So today we will try this 5 preprocessing technique, and tomorrow we will do on derivative part and machine learning, deep learning, Azan. So now I will open MATLAB and we will together do coding, and I will explain at each step what we are doing. Keza?
Okay.
So shall we do 5 minutes break before we continue?
Yes. I also thought like sitting in the morning. Yeah, before you start the spectral pre-processing, I think we should have a break. But you continue, so I let you continue.
Okay. So let's have 5 minutes break, and we will start coding after that.
Okay.
Yes. Hello, Azan. Hello.
Hello, I'm here.
Oh, okay. How are you, June?
No, that is L.
No.
June.
Yeah.
June is here.
Yeah, I think June just spoke. How are you?
It's a long day.
Yeah. Now, till tomorrow.
Yes, but I understand.
Uh,
It's teach na.
like, if you have any other questions, you can ask me like later or anytime.
Thank you so much.
Okay. Azan. Okay. So.
Azan. She is not there, I think. यहाँको नेटवर्कले के बेरियर गराएको जस्तो लागिरहेको छ मेरो खोल्नलाई नो इन्टरनेट कनेक्सन
Hello, everyone is back or not?
Yes, I'm in class.
Okay. So I can start.
Me.
Yes, I am here.
Okay.
And like
L.
Yes,
Yes,
yes.
yes.
okay. So yeah, today we will do up to this 5 pre-processing, which are like a more simple one in terms of coding also. And tomorrow we will do on Savitzky-Golay with first derivative and second derivative. And one more is I want to do with one is smoothing, which can later be applied together with other pre-processing techniques. So now we will work on coding. Today we will, I have not given any MATLAB files to you. So we will all work together, try to understand the code. And tomorrow I will provide you the MATLAB files so that it will be easy for you to just call the function and do anything. Okay. So everyone can now start on MATLAB. Okay. So today we will use what do we call this one? Command line only. So all of you, I think, have data inside the working directory. Just make sure the data is inside here.
It is free. I think everyone can open the mic and then do together because it will be a little bit more interactive. If not, then someone may be behind, someone can do fast. So please open mic and then talk and then do.
Okay.
So everyone have file in the directory, right?
Yes.
Okay.
Yes.
Okay, as I told earlier, we have TSS as a response variable, and these are the wavelengths. So for tomorrow, if you want to do in your own data, then I will like to request you to format in this way. I think it's easy for you also, right?
For June, TSS will be maybe some component, and
yeah.
then for L, the first column will be the geographic origin.
Yeah. And I will also have my own data set. So even you can do that in my data set and later implement in your own data set is fine. So okay, I'll start sharing MATLAB and okay, let us work from scratch. So if there are anything, it's popular command in MATLAB. So we will clear everything and clear all the variables also. So and make sure you can see your data, the data set that I provided in the current folder window. Okay, so so there are a few steps in pre-processing. First one is I'll just make a comment loading the data set. So as you know that this CSV file is in tabular format. So there is one library, sorry, there is one function that can be used to read the CSV file. So for our case, we will use one function called read table. So, and one more thing, if you are not sure about the function name. So after you type something, you can just press on tab. So it will give you a list of command. From that, you can just select and press enter. So, so as you know, this read table is a function. So we have to pass some argument, some parameter inside this one to read the CSV file. So first parameter will be the data set. So this data mango soft.csv, and then I will pass some more argument. So as you know that the first row is just the column name, right? TSS and wavelength. So we want to read those variables. So we will pass another variable name called read variable names and true, so that it can read the variable name on that first row. And we need to define which row. So So we pass 4 arguments. First one is the data, and second one is we want to read the variable, that is the first row, and we want to read the variable as it is. So if we don't put this one, then it will create the variable in a different way. And last one, we need to say which column number is the variable. So for our case, it's the first row. So we define these things. So make sure the spellings are correct. So as you can see, for me, I have successfully read the variable. And if you go to the workspace window, you can see like 182 into 1056. So that means that there are 182 samples, and there are 1056 variables. That means 1056 wavelength readings.
Excuse me, Sumed. Could you copy this line to maybe PowerPoint, because this line is very small for me.
Oh, I see. Okay. Uh, in the PowerPoint, right?
Yes.
Please show your MATLAB again.
Just a moment, I'll show it. Where is it? Okay. So this is the statement that I wrote to read. So
Please tell me what is the meaning of your this you wrote?
okay, so you mean about this function, right, Azan?
Yes.
Okay. So we are passing 4 argument. So first one is our file name.
Yeah.
Okay. So as you saw in this slide, okay. So we have these are the variable names. Okay. So we have TSS and wavelength, right? So first row.
Yes.
So I want to tell to function that, okay, first row is not the data, but just the name of different column.
I see.
Okay, so that's why I wrote these things. So I told, okay, read the variable name true. So true means it will read the variable name. And we say like here, variable names line. So it is in first line. So we pass, okay, it is in first line. So this line 1 is like TSS and lambda. This will, and we have data over here. This is data. So it will not read first line.
Yes.
So everyone completed this one.
May I ask the 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 name variable name rule, this is your create or not, or is the MATLAB language?
It is from MATLAB language, Suzanne.
Oh, variable name rule, variable name line like this.
Suzanne.
Oh, thank you.
My MATLAB show unknown parameter variable naming rules.
Oh, okay. What is your version?
My version. I check.
For me also.
I'm not sure.
Okay, just check it.
You can see MATLAB R2018A or MATLAB R in the top. There is written
2020.
20.
Oh, mine is the latest one.
21.
I used your license for this session.
Wait, 2020B.
2020B.
Yes.
Yeah, 2020B is our university license, for our university license.
Yes. So June have 2020B, right?
Yes. A 2020A.
Can you once show your screen to me? share your screen.
Ajahn version is 2020B or 8.
Yes. B.
So you can already read, right? You can execute the command.
Yes, I can. I can.
For us, we cannot
Okay.
Hey, why?
because the version is old version for me also.
Oh, because you use our lab license.
Yes.
Ah,
But Sumesh use license from KMITL.
Mm.
oh.
Yes, it's the same thing.
Okay. Okay, just let me check. I will check in Sneha, and if it works, I will share what needs to be changed.
तो उन्हें देखा देने से जीत करता है
Okay.
Middle description property. Naming. The version of Dilgani Sapalana.
No. And for PMA and L is fine, right?
No, for me also.
Oh,
Oh, why?
You can copy and place in the comment.
No,
And
no. Maybe because may also use the old version, right?
Yes, yes.
So I think we need to have the same version.
No, no.
Everyone.
Okay, I will do in a different way. Then I will use another way because otherwise we'll have problem later also.
I think we should have no problem, because everyone KMITL student, they can use 2020B.
We can update.
Yes.
Yeah, but it will take time, so I will use another approach for now. And
For tomorrow we
for
update.
tomorrow, I think if you can upgrade, then it would be easy for me because I've already prepared some other materials based on 2020B.
Yeah, we can June, May we can update MATLAB to 2020B นะ
ของพี่ L is the 2020B but it
Yeah,
can't.
L is fine.
Oh.
L use 2020B.
Oh.
Okay, no problem. I will use another approach for today, and tomorrow, if possible, please upgrade. It will be easy for me.
Okay, so wait, tomorrow I will update.
Yeah.
Okay, me too.
This is the one. My team, Microsoft Team is stuck. I cannot share. Okay. It's fine. Okay, so we will use a little different approach for today to read the data. Okay, I will share the screen and we can continue. Okay, before I show to you to read using read table function. So now we will use another function. Like there is XLS read command, and we just pass data and close and end by semicolon so that it will the data will not be printed.
Should I do the same also?
Yes, Azan.
Okay.
Okay.
Editor specify the font.
Environment. Font, where is font?
Oh no, it doesn't work for me. Oh, okay, okay, okay.
Okay, is it fine for everyone? I think for Isnia is also okay now.
For me, it's okay.
Okay.
Okay, so I think we are ready to move now. So now we just read the CSV file using XLS read. And as you can see now, before it was 182 into 1056, because a read table will not take first row as a data, but here it is reading first row as a data. So we have to do a little different approach. First of all, I will show you the matrix slicing to show a small portion of the data. So you can type T. So now we are passing row and column. Okay, I will slicing. We are slicing T. I will just show from first row to fifth column and from first column to fifth column. So it will be like 5 by 5. I will read the first 5 by 5 section of the table. So you can see this is TSS value, but the first row is converted into NaN because XLS read cannot read the categorical data because this column is the mix of numeric and string data. So it cannot read string, so it is converting into NaN, and these are the wavelengths. Is okay, right?
Yes.
Okay, so now we will divide this data into Y component and X component. Okay, so X component is Y component is this first column. So this first column is Y component, and actually Y starts from second row. So what we do is Y equals to from the this matrix T, we start from second row until last. Yeah. So before doing that, I will need the number of rows and column. So what I will do is how many row in T and how many row in column. I will read the row and column of file T. So there is one operator function called size T, which will print number of row and column. So T row, you can see there are 183 row and T column. So in T matrix there are 1056 column. So now we can read Y data. So Y data will start from second row. So this is second row until the last row. So last row is this T row, and we are reading only the first column because first column is TSS. So we pass 1. And semicolon. So now you can see on the right side. So yeah, so now TSS is assigned as Y, and there are, as I said earlier, 182 samples. So we have a row vector of 182 elements. So likewise, now we need to extract the X or the predictors variable. So which will start from here. So from here, like it will start from second row and the second column, right? Is it okay for everyone? Can you understand what I told?
Yes.
Okay, so I think I will not type first. First, I will let you type to extract Y. So Y we will extract from second row and second column until last. So can you first do it and then I will do
X, not Y.
Can you extract Y? Sorry, X. X.
What? Please speak again.
So just now I showed extracting Y from our matrix, T matrix. So now we need to extract this x variables, like for wavelength, starting from here. So this is second row, second column. So we need to extract from here to the last column, last row. So can you do that?
I cannot.
Okay. Okay. I will wait for other. May, June, L.
Understand. Can continue.
Sorry, June finished?
Yes, I'm finished.
Okay, good. What about May and L? Okay, Ajan and I will do together then.
Yeah. I follow you.
Our data is from second row. This is second row. So we will go from second row to last row. And for column,
So,
yeah. And for column, our data is from second column, from here. So we go from second column to the last column. And just press it. So now you see here our x and y variable have been created. So y is TSS with 182 elements and x with 182 samples with 1055 variables. So now we have x and y, but I want to extract these variable names because when I plot the graph, I want to show the wavelength. So can anyone do it for me? I want to extract wavelength from second column, first row, second column to first row, last column. What do I need to do?
first row.
Second column until first row, last column.
One
And
semicolon.
Colon.
I think no need.
One.
We want to do first row only.
Oh.
And then from second column to last column is T-code. So now we are ready to view our raw spectra. Okay, so we will plot. So can anyone plot the wavelength and the x component first? So we have as a in x-axis we will have wavelength, and in the y-axis we will have the spectra. So spectra is now denoted by x, so we will use that one. And for now we will only use these two things to plot. I think you can see the raw spectra with what is it? As I showed in the slide.
Yeah, I have a problem.
who have problem can see your screen.
I
Oh, okay. You can share the screen, and I can.
What I say?
Thế thì just bảo.
The one no need it.
June, you just shared, right?
Yeah.
X. That's fine. Either.
Using tablet blocked.
Oh. Okay. Okay. June, can you share your screen once? Like
Share screen.
yes.
only my screen, right?
Yes.
Yes. For other is fine, right? You can see the raw spectra.
Yes.
Adhan can see?
Yes.
Okay. Viewer na itagan to sa
Okay.
zoom गर्न मिल्ने रहेछ उसको पनि त्यस्तै है
You कसको problem?
यो त L को
Yeah.
L also have problem?
Yes.
Okay, I'll check it. I think you missed one line. Because now we are reading data using this one, but I think you did not type this line. Because in the workspace I can see that T is table, but actually T should be of type double now. So over here, I think you have to import using XLS read.
Yeah.
And then it will be fine. So after you read, you have to do all the lines again.
Maya.
The line देखेको न Yeah,
same problem with June also. because like it did not work in your MATLAB version, so we changed the plan to read CSV file using XLS read, not read table.
Can continue.
Okay. So now let's add some component in the graph like title, X label, Y label, and some more things. Okay. So first we will start with title. I don't know what to put, so I will just put raw spectra for now. So after you press enter, you will see the change in the figure. Likewise, X level, we will
Wavelength.
so nanometer. Y level, would this is absorbance, right?
Yes, absorbance.
Absorbance log 1 by R.
Oh no, yes.
So, and to make it usable for manuscript, I want to add some more like font. So you can do modify using set function, and GCA refers to this graph. So font name, I think better to use Times New Roman. And another is I will set the size. I will set the font size to 14 so that it will be a little big. Okay.
In this one, I don't think we have Times New Roman and font. No completion font.
I will.
Type the variants.
Okay, did you complete, everyone complete adding the elements of the plot?
No.
Wait.
Okay, it's fine.
I can get it because I wrong some code, but now it's okay.
What about the L? Is working now?
Working. Sure.
What is set GCA? What is GCA?
Okay, Azan. So this GCA refers to the setting of this our figure. So this plot. So you can see. So we are trying to change something of like font size, font name of this plot. So GCA refers to current plot.
And then 14 is the size of the font.
Yes.
Yes, Azan. Font size.
font name.
Oh no, I got error.
อาจารย์
DCA font size
and then
comma.
bracket,
Oh,
square bracket.
yeah. Set DCA comma. Oh, I wrote font Thai. Okay.
How about everyone?
Finish.
You can get the data, you fix the error, right?
Yeah.
Sneha,
Yes,
when you wrote your paper, you
Yes.
use the MATLAB graph function to put your paper, or you work on Excel?
For that one, I got it from Python, ค่ะอาจารย์
Oh, from Python, no?
Yes.
And we can use MATLAB graph. No need to put in Excel.
Yes, if you want to code in MATLAB, then we can use like this, ค่ะ
Put in the paper, in
Yes.
the manuscript.
Yes, and we can save this image
yeah.
and then we can put.
Oh,
But
I see.
the thing is, when we generate the picture from MATLAB, then we have to make it like a, how to say, graphic. It's not the Excel or Microsoft Word version, so we have to make it graphic.
Oh, I see.
So that's why normally,
Correct.
yes, it's better to use Excel when we do for manuscript ค่ะ
Thank you, Sneha.
ค่ะอาจารย์
Okay, so now we just create, but if we want to save the figure, then we will have to write one more command. So like you can write save as, and to denote current figure, we use GCF. So this means current figure, and the name, like I will say raw spectra .png. So you can use other format for saving, like JPEG or even TIFF. I think PNG is okay for now, but if you want to change later, then you can change.
And also for the image, for the picture, we can set resolution like 300 dpi, right? For manuscript, we need 300 dpi.
Yeah, I think the default is around that one, so it should be acceptable. Let's see the figure. Okay, so we pass the current figure as first argument and the name of the figure as second argument. So after you enter, I think you will see the graph on uh, the image on the workspace directory. Is over here. So and you can view here, but maybe too small. Yeah. So here you will see little course because you are opening from this window, but if you open from Files Explorer, then it will be clear. everyone could save the chart, right?
I cannot save,
Oh. So
I wrote save as already, but I cannot put the picture in the like you did in the current folder. No.
you did not see PNG image.
Oh, I see. Okay. Yeah. Now I see.
Okay. So now we will move forward. So second one, I want to show the distribution of TSS value. So for that, we will plot histogram. So now you know that we need to put this like title, X level, Y level. So for like, since we need to cover many things, we will just plot, and we will not set the title or anything for now. But when you do for like a paper or something, you have to do this. So now to plot histogram, there is already, we will first create new figure. So you will see an empty figure after typing this one, and now we have SSTO histogram, and we will pass our Y data. So for now, we will not set beans, but later you can try setting beans, like how many, like
How many
interval. So now I want to move to spectral preprocessing, so I want to just show these things.
Yes, now can see histogram.
So everyone can see histogram.
Yes.
Oh, okay. So yeah, I will not interpret the histogram or anything, but I will continue. So later we can analyze like if we get good or bad model, why is it like that? Anything.
But this is normal distribution.
Yeah, it's good.
Yeah.
It's a kind of good one. Okay, so let us start with the simple one. So first we will do with baseline offset. So in baseline offset, we are subtracting the minimum spectra value from the spectra. So the first baseline offset. So for that, I want to read the number of row and column in our X matrix equals to size of X. So if you see, so we have 182 samples and like 1055 predictors. So first we will extract minimum value of each spectra, like of 182 spectra. So for that, I will create one variable called mini spectra, and I will use function mean. So if you remember, the mean function will extract mean in mean column wise, but in our case we want to extract mean value row wise because the spectra is in row direction, so we will have to rotate our matrix. So we will do X bar.
Transpose.
So you can check the histogram of mean spectra, like minimum value of each spectra. I think the range is not that big. Yeah, seems like majority of spectra has the mean value, minimum value around 0.3 or 0.35. But okay, but our objective is to subtract this mean value from corresponding spectra. So I will do step by step. So I will create one temporary matrix. The transpose multiplied by one and so I will explain this in what do you call
In the slide.
in the slide. Okay. So now to get the baseline corrected data, you can now subtract temp one from the raw data. So baseline corrected equals to, we have raw data is x minus temp one. So temp one is the matrix of minimum value of each spectra. So now if you plot wavelength and the base, sorry, I missed. Sorry. And I plot wavelength and baseline.
Okay.
Everyone got the baseline corrected data plot, right?
I am following.
Okay, that.
Oh no. Yeah. Yeah.
If we don't in the line mean, if we don't transpose it, what happen?
So if we don't, where did you say?
When we change the row to column, because the graph was in row, and then we transform to column because we want the matrix.
I will explain from PowerPoint. Okay, so okay. The first one is this. So you have to remember about your data structure. So you have data. Okay. So here is sample, right? Sample, and this is your lambda.
Yeah.
So like this is the spectra. Spectra of sample number 1. Is okay, right?
Yes.
So in baseline, we need to, for baseline correction, just a moment. Okay. So for baseline correction, we need to find a mini spectra. Mini spectra of
Mini spectra from all spectra.
yeah, mini spectra of each spectra. So we did transformation over here because this mean will calculate column wise. Actually, mean will calculate column wise, but we want to do row wise, right? Because our data is in different form. So that's why we transform. So after we transform, our data is like lambda is over here and our sample is over here. So now we can calculate mean so that we will get column wise, like minimum of each spectra. So this is for this line, and now for this one, so here this is matrix multiplication. Okay.
Okay.
So this refers to matrix multiplication. So currently, if you see here, so mini spectra now is in this form.
Yeah.
But as in final, we want our spectra to be in same form like the original, like sample and this one. So
Yeah.
we have to use transformation, transpose here and multiply by this one. So we will get
Original back.
So what we will get is minimum value for all wavelength. So, and we are subtracting minimum value from all wavelength, right?
Yes. One comma and call that identity matrix.
So you understood, June?
Yes, I understand.
But still I don't understand, why you have at first why you have to transpose
Okay. Here, right?
why you cannot calculate minimum of absorbance by mean and then only x only, so the x will be the point of x minimum will be gotten, right?
Sorry, Azan, I did not hear clearly.
Yeah, I tell you, I ask you, you said you want to get the minimum point of the spectrum, of the
Yes, sir.
absorbance of the spectrum.
Yes, sir.
I thinkดัง to get the minimum point, you can write mean and then in a parenthesis x only?
Actually, I have to transpose because our data is in this format, Azan.
Yeah.
Because we want to calculate a minimum from each spectra, from
Yeah.
each spectra. So we have to do in this direction.
Yeah.
In the row direction.
Yeah, but this minimum will calculate in column wise in this direction.
You mean the minimum number of the minimum value of the sample or the lambda?
Actually, we want the minimum value of spectra, right? But
Yeah.
if we don't transform, it will give the minimum value of wavelength.
Of lambda.
You understand the point? Like for baseline offset, we need minimum spectra, minimum of spectra. If we calculate in this format, we get minimum of lambda, not spectra, because minimum of spectra is in here
in row.
In this side is the minimum of spectra, but in the matrix it calculates minimum by column, not by row. So we have to transform row to column like that.
Oh, to get a minimum, you have to calculate from the column wise.
Yes, Adan. And then now it is originally it is row wise, so we transform it to get column wise.
I see. Yeah. And another thing, you know, Sumit transform back to the row wise again using the command that multiply by ones and one comma and underscore column.
Yes,
So as 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 far as I remember, P-solver said is about permit or permut.
About?
He said something. The command is permut, permute.
Permute or rep map. Yes, like there are different approaches. I have been doing like this in Python, so I use the similar approach.
Oh, so you know the function of permute?
Not permute. I think it's rep mat.
It's the what?
REPMAT.
REPMAT.
Repeat mat. Repeat copy of array.
Yeah.
Rep mat.
Oh, that's I don't know.
Yes, like
I just asked.
yeah, it does the same thing. I have checked with another approach also, but I find this approach easy to make other understand. So like from this mini spectra, we will have the transpose. That mean we'll have one. Its size will be 1 into uh, n row. Yeah, number of sample, and here yeah, so like we will transform this one, so it will be nr into 1, and when multiplied with ones, that one we will get a matrix. Yeah, so from this statement we will get matrix like that, like this one. So sample and lambda and minimum value for each sample. And then we subtract minimum value from the original spectra, and then we get the collected one.
Yeah.
Okay.
So the function of ones, what is the function of ones?
Okay. So here, this ones will create a matrix of like one row and one column, all element as one.
Oh, I see. Mm-hmm.
Yes, now I check the code of PSOP. He used RepMat ค่ะอาจารย์
Rep mat เหรอคะ
Yes.
So shall I continue with the coding part?
Other part. Other technique.
So yeah, right now we completed baseline. So we will now do with other approach, like second we will do with mean centering.
Mm.
So in baseline we extract the minimum value for
Mean
centering. For mean centering, we will use extract the mean value of each spectra, and then we will subtract in centering to center the data. Okay, so we can calculate mean value as mean, same like in when extracting minimum value. So just the transpose. And we will create like before. So we will create a matrix, same dimension. Data. Sorry, I think I made a mistake. Yeah, n code only, not codes. So now mean center. Okay, mean center is now raw data minus mean of spectra.
Oh.
Center. So second, now you got the mean center data set.
Oh, I can only tung ning. I don't know why.
Got some error?
Yeah, I'm checking. Oh no.
L May
Yes,
can do it, right?
yes, yes.
L why very silent now?
It's
Can,
the
can.
characteristic, you know. It's the L characteristic.
L characteristic.
Keep quiet, keep quiet.
Saneha, if
Yes.
I want to go back, in the save by baseline, can I like a type after save mean center?
Uh,
If you want to go back to baseline.
I think if
I
you
want to save the picture.
Save picture.
do you have that figure is still open?
Pardon?
You have that baseline corrected figure is still
Picture,
open?
right? Yes, yes.
Okay, so from figure you can go to file and save as for now,
Okay.
and then save as like PNG in the same directory.
Okay.
So next I will start mean normalized. So in mean centering we will subtract mean from the spectra. Uh, but in mean normalized we will divide by mean, so that is the only difference between two approaches. So we have already calculated mean, and so what we can do is it's quite easy. So we just say mean normalized is x divided by temp 1, because temp 1 represents the mean matrix of the spectra. So okay, so we cannot divide directly because we are doing element wise. So we have to pass dot uh, divide sign. I think divide sign is not this one.
Yeah. May I ask Sumit?
Yes, sir.
Mean you write mean underscore and no is the your own variable, right?
Yes, Azan. I mean to say like mean normalized.
Yeah.
Mhm.
It's not MATLAB, right?
No.
It's your variable.
Variable name, yes, Azan.
But I don't know where can I find the backslash.
Backslash.
It could be below backspace, Azan.
Below what?
Backspace.
I think near shift.
Uh,
Near shift in question mark.
Enter.
Yeah. Oh, I see. Okay.
Second is the slash. Do you mean is the slash?
I think yeah. So
Forward
I think,
slash.
yeah, it's forward.
Not backward.
Oh no, but I cannot see your is mean normalized?
I mean normalized. I think I used the wrong sign. So
Is
I see.
is forward slash, not backward.
Oh, I see.
Dot
divide by
temp 1.
temp 1. So because mean.
Finished for everyone?